Hello YouTubers, now in this video I will be covering the example of HTTPS request from file examples into ESP8266WiFi, and this is HTTPS request. So after watching this full video, you will come to know about how you can connect ESP8266 with your router, how you can establish a communication with the server using ESP8266, how you can establish a secured communication using HTTPS protocol with the help of ESP8266, then what is the concept of fingerprint in HTTPS protocol, and how to fetch data from that server. So these all are the 4 or 5 things you will come to know after watching this full video. So let's get started. Okay, so first of all, let me brief you that what this code is meant for. So in this code, the ESP8266 first of all will connect to your hostname and password or your router. After it gets successfully connected with your router, it will establish a connection with the GitHub server using HTTPS protocol via port 443. This all we will discuss further. So after establishing a connection with the GitHub server, it will go into the address which is mentioned in the code, and at that address it will fetch the data, and the data will be displayed in the serial monitor. So this is the basic application of this code, and with this example you will definitely come to know how you can establish a communication with the HTTPS protocol. So in this video you will learn this example, and also you will able to edit this example, and you may use, or you will be able to use according to your application. What I will do, I will go line by line and explain each and every line so that you can come to know about each and every functions used in this code. So starting with there are necessary declaration of the two libraries, which is ESP8266WiFi and the Wi-Fi client secure.h. These are header files. After that it's asking for the necessary name and password. Okay, let me open my edited version of this code, in which I have already entered all such things, and also I have used the comments so that you can better understand this code. And no worry, I will be uploading this code into my GitHub account, and the link of this is available in the description. Okay, so I said name and password here. It is written as SMS and SMS 123458955. So you need to edit it according to your router. So after that you need to enter the host name. So for particular this example, the host they have chosen is the GitHub. So the host name or the server name address is written as api.github.com, and the port here used is 443 or 443. So port is basically can be considered as a pipeline through which the communication will be established, or the data will be transferred. So there are different ports for different protocols. For example, for HTTP protocol the port number is 80, and for this HTTPS protocol the port number is 443. So difference between HTTP and HTTPS is that HTTP is non-secured version and the HTTPS is the secure protocol. So after that comes the concept of the fingerprint. Okay, so in HTTPS protocol, so first of all let's talk that how HTTPS protocol works. HTTPS protocol works on the public and private key. There are two keys in this whole concept. So public key is open for all, or open for all. So this is the common key which everyone will have, while private key are unique for single system. For my system it will be unique, for your system it will be different private key. So what happens is that whenever we are requesting a link, or whenever we send the data, we use this public key of that server, and that server will come to know our private key. So next time whenever the server will be sending the data, it will be sending with the private key of our system. So in case if there is a hacker in between our communication, in our communication, which is trying to access the data, won't be able to read the data, because the private key of his system or that system will be different than my system. So he won't be able to observe the data or observe the communication. So this is how this communication becomes secured using this public private key. So how to find this public key? So you need to go to this website or the server. So first of all I will open the Google Chrome and type api.github.com. Okay, as you can see that here it is mentioned it is secured by HTTPS protocol. So how you can find the public key? You can go to inspect, you can go into the security and click on view certificates, click on details, and the last detail is the thumbprint, which is nothing but a fingerprint. So this is the fingerprint or thumbprint which I have mentioned here. As you can see, the 358574 and up to 2E19. Yeah, this is the fingerprint. Now this is the public key. Everyone will have this public key for GitHub account. So any browser or anyone can establish a communication with that GitHub account. So GitHub account will respond with a private key, so only the particular user will be able to observe the results. So this is how the communication is secure. Okay, one more thing which I need to tell you, that if you observe the examples, let me show you example HTTPSRequest. This is the example from the library, and this example is also meant for GitHub account only. So the fingerprint here mentioned on the left hand side is for GitHub, but as you can observe that both keys are different. So this is something you must need to understand. Okay, so this type of keys are regularly updated, because as you can see that the key on the left hand side doesn't match with the key on the right hand side, because the code which is written in the example is the older version. At that time this was the key for the github.com, but at present the key is changed. So you need to update the key regularly. So this is something you need to keep in mind whenever you're using the HTTPS protocol, that you must always use the updated key. Okay, so moving ahead in the code. Okay, so we are now jumping into the setup. Setup, it is written as 115200, the default port rate of ESP12 board. After that, it is showing connecting to the SSID. Yeah, this is the function Wi-Fi.begin. It takes two parameters, SSID name and password as a character pointer. So this function Wi-Fi.begin will establish a communication with your router with the parameters you have entered above in the code. So after that, if this is connected, then the Wi-Fi.status function will give response WL_connected. So we are just polling this Wi-Fi.status function unless it shows WL connected. If it is not showing WL connected, then it will be in this loop forever. So it will continuously printing this ... So as soon as it is connected, the status will change to WL connected. It will jump out of this loop and it will show that Wi-Fi is connected. Now after that, you can find the local IP address of this ESP8266 Wi-Fi by a simple function Wi-Fi.local IP. As it is connected with your router, it will get a local IP address, which you can see by this simple function. Okay, so after that, in the code, it has created a client object for the class Wi-Fi client secure. So now with this client, we will be doing the further actions. Okay, so now ESP8266 is successfully connected with your router. It got the internet access. Now it will try to establish a connection between the GitHub server to this embedded system or the ESP8266. For that, the function is client.connect host and HTTPS port. It also takes the two parameters, which is host and the port. Host name is already defined above, is api.github.com, and also we have defined the port as 443 for HTTPS communication. So if it is not connected, it will show connection failed and it will return. Now this simple line, the return function or the return line, will throw our code to again start from the beginning. So if it is not connected, it will again go to the loop and start it again. The whole procedure is repeated if it is not connected. If it is connected, successfully connected with that server, it won't be going inside this function. So after that, it is written as client.verify fingerprint, host. Now this function will verify the public key of which we have mentioned inside the code with that of the server. Now here you can do one thing, that if the certificate doesn't match, you can type here as a return, so that the code won't run ahead if the certificate doesn't match. Right now the code is written in such a way that if it is matches or not, doesn't matter, the code will continue ahead. Yes. So it's up to you. If you want to stop, you can just add a little line here, so the code won't be running if the certificate doesn't match. Okay, so after this certificate confirmation, it will be going inside this address, which is repos, ESP8266, Arduino, commits and masters and status, all over. So this is the address from which we need to fetch the data. Okay, now here is the something which most of you must not be knowing, that requesting a link in a browser doesn't means that only we need to type that google.com/images and something. On the background, what is happening is that a link is created in a proper format. There are some headers in it which are necessary, which are required to be sent to the server for necessary details. So here ESP8266 is not that much smart as our Google Chrome. So here we need to tell ESP8266 that in which format we need to send the link, what are the headers we need to include. So everything is manual in this. So let's see in what format the link will be requested. I have written in the comment in an easy manner. So first of all, this is the get request. So get After that, after get, we need to we need to specify the address. So here the address I have pasted here. This is the address. So I have pasted the address here. After that, we need to specify the HTTP version, which is 1.1. After that, in the next line, we need to add the headers. So first of all, the first header is the host name, which is api.github.com. Now the second header is user agent. Now what is user agent? So basically, user agent header will contain some details about our system, some details about where this link is coming from, which browser or which system. There are some details which are contained in this user agent. Okay, in a few seconds we will see how Google Chrome sends this kind of headers, or where you can observe that these headers are being sent from your browser. So we will talk in details further. So right now you can consider that this build failure. Okay, I have removed this copy and paste. This build failure detection ESP8266. This is something which identifies that this link is coming from this ESP8266 module. So this is the basic meaning of user agent. And after that, the connection status. What you need to do after requesting a link or after getting the data. So what I have mentioned, or what the coder has mentioned, that we need to close the connection after all the process is done. So these are the headers which are sent along with our link. So after this, it will print the request is successfully sent, and after that it will wait for the response. This will read the string until new line is obtained. Okay, one thing is that the response coming from the server side is always in a string form. So we need to create a variable, a string variable, and store the response in that. So until new line is received, it gonna read and save that response in the line variable. After that, okay, here it is checking about or it is confirming that the received data is the targeted data or not. So first of all, let us go to that page, so that it will be easy for me to explain you. Okay, so this is the page. I will close this. Okay. Okay, so this is the page, or this is the page from which the ESP8266 is trying to access the data or fetch the data. As you can see that this line is confirming that is the data or is the received string is starting with this particular format, or the state :success. Is it starting from these little line? If it is starting with this, then congratulations, you have successfully received the right data. And if it is not starting with this, it has failed to receive the data. So as you can see that the starting line of the whole page is state: success. So this is basically for confirmation. If you just delete this, this code won't be affected, not at all affected. Yes. So after that, after confirmation that the received data is the targeted data, it will print out the whole response. It will print out this whole response in the serial monitor. So this is the code about HTTPS request. So let's upload this code and test this. Okay, after as the code is being uploaded, I will let you know that headers. So I'll go to inspect, and in the inspect you need to go to, I think, networks. Yeah, in the network. So I will again request this link. Okay, in the status I will be getting the header. Yeah. Okay, let's put it for github.com only. And okay, as you can see that these are the request headers. The number of request headers are 9. So nine headers are requested along with this link. So what are they? So this is one of the header which we have used, which is connection. Now Google Chrome is using the keep alive connection. Means that after successful data transmission, don't close the connection, keep it alive. After that, there is a cookie header. There is a host name which we have included, which is same, which is api.github.com, because the server is same. After that, this is the user agent. As you can see, there is a detail about the server. Let me make it big. Okay, this is Windows 64 system, and this is Google Chrome about and Google Chrome and its version is written. So this is basically the details of the system from which the link is coming, and all other headers. I exactly don't know about what you can say application of other headers, but yeah, this is the particular format in which the link is requested through a particular browser. Okay, so our code is uploading is started. So let's wait for the completion. the serial monitor. Okay, showing connecting to SMS, which is okay, successfully connected. Certificate matches, and yeah, the received data is successfully received, means what you can say, comparison was successful. And after that, this is the response. So this is the whole page which we have seen. Okay, again I will open that page. So this is something we have received in this serial monitor. You won't be observing because this is the response we got in a single line. So it may look something odd, but yeah, it is the same, that URL HTTPS API github.com repo something which is written here. Okay, so this is the example which let you know that how we can establish an HTTPS connection, how we can talk to the secured server, how we can fetch the data by comparison of fingerprint and all. So likewise I will be explaining all other examples. So stay tuned for next such videos. Till then, explore, learn, share with me, techiesms.